about simultaneous equations. So you don't need anything in your hands, you can put everything down. You're just listening for now. So iPad's face down, everything out of your hands. So we've addressed some of these, but we probably haven't looked at them as a group. We haven't looked at all three of them, we haven't looked at them as a group. So just to remind us all what simultaneous equations are, what we're trying to do is we're trying to find when two functions meet. Now what are the type of functions we've dealt with today? When two starts with L, linear functions meet. Two straight lines meet, correct? But it doesn't just apply to linear functions, it can apply to any type of function. But we're really good with linear functions, so that's where we've started. Simultaneous equations are all about finding out where they meet. So if we're looking to find out where things meet, there are three ways in which we can do it. We can do this visually, or we can use algebraic aids with simultaneous equations. I want to talk about each three of those methods and why we use them, some of their strengths and some of their weaknesses. In reality, I'm going to be clear straight up, in reality I only use two methods unless I'm teaching the third method. The reason I use two methods is because I'm lazy. I like to remember as little as possible. And that's one less thing to remember. I know I'm a maths teacher, I know the method, I just prefer to use a method I'm more comfortable with.
I know, but it's okay that you're lazy.
It is, that is right, very true. Maths is all about shortcuts, but shortcuts are for those who know the way. So I'm going to show you the different ways. You can choose which you prefer from there. Okay? The first method in which we can solve it is using that visual aid. Does anyone know how we could solve, or if I ask you a question, where do two functions meet? How could I do that? Graph the two lines. Yep, that's it. So method one is graphing. Okay. So I could just have two lines here like so. I'm just going to make a coordinate up. Okay, and that point there I would describe as 1, 2. Very simple graphing, isn't it? Yeah. It would be 2, 1. Well done, you passed the coordinates test. Well done. There's always tests in my teaching. Very good. You passed. Always be alert. Okay. What's the advantage of graphing? Could you do that with any type of function? If I gave you any function, could you do that right now with your level of understanding? You could just shove it into Desmos, couldn't you? And look, and it'll tell you where it is. What's the disadvantage? Who's expecting to use Desmos in their exam? Who's expecting that I'll say, alright kids, get your iPads out. Free reign. Am I going to do that? So it's great when you've got the technology, and in year 11 and 12 there are times when you're going to have access to graphing calculators which will do that for you. But there's two exams on a year 12 paper, the Tech Active and the Tech Free. Simultaneous equations come up in both of those exams. Cool? So if you haven't got technology, what's the problem with this style?
It doesn't work.
Doesn't work, why not?
So we've got an iPad to show you what it is.
You need an iPad to be precise, hey? Because our lines, when we draw two lines, are they exact?
No.
And how do we know when it's 1.334 versus 1.332?
Desmos.
Desmos. But if we haven't got Desmos, we haven't got that tool, correct? So graphing's the first technique, and it's really good because it's quick, it's easy, and it works all the time, providing we have the technology. But we don't always have the technology, do we? And sometimes graphing problems isn't appropriate. So quite simply, with this method, what do we do? Shove in functions, inspect where they meet. If I don't have Desmos, I can still do this method, can't I? I just sketch the functions by hand instead. Cool? Are we happy with that? Do you like breathing?
No, really.
Oh, you are awake. That's good. Lachlan, please don't ask me a question he's saying. You'll notice I have more than one method on the board. Do you have any inkling?
No.
No idea. No clues. Do you reckon we're going to solve it visually? Or are we going to use a different technique?
Simultaneous equation.
Very good. Simultaneous equation. There's two methods in which we can deal with simultaneous equations. I've given you exposure, heavy amounts of exposure to one. Does anyone know the name of that technique?
The visual aid.
The visual aid is our graphing. There's a special name for our simultaneous equation. Harry?
Substitution.
Substitution. Very good. Okay, now if I gave us two equations, and I like to give us an example when we're going through this. If I gave us two equations of 2y plus 4x equals 10, and y minus x, or 2x equals, I don't know, 2. Let's just go with that. I have to have how many equations do I need for this to work? I need two equations. I label them 1 and 2. What do I do with these equations now?
Rearrange into y equals plus c.
I rearrange. Doesn't have to be into y equals mx plus c. It's often the nicest way. We rearrange to isolate a variable. What's a variable?
Unknown.
An unknown. How many variables have both of those equations got? 2. Are they the same two variables?
Yes.
Y's and x's in both, correct? If I had y's, x's, s's and t's, could I do anything about that? No. I need two variables that are the same in both equations, correct? When I say the word isolate, what does that mean? We're all COVID aware now. What does isolate mean?
By itself.
By yourself. So I need to get one of these variables by itself. It doesn't matter which one. Ethan, looking at these equations, which equation would you attack? Equation 1 or 2? 2. Why would you attack 2? That's one I'd attack as well. Why? Looks easier? Perfect reason. Alright, so I'm going to rearrange 2. What should I get by itself? Y? Okay, how do I get y by itself?
Plus 2.
Plus 2x to both sides. So I've got rearranging 2. Y equals 2x plus 2. Happy with that? I'm just going to, because that's exactly the same as 2, I can call that 2, can't I? Or I can call it 2a. Let's call it 2a. Sweet. What am I going to do with 2a? What's the name of this method?
Substitution.
Okay, that's a hint. Mitchie, what am I going to do? Who plays any sport?
Sub 1 into 2.
You sub 1 into or 2 into 1 in this scenario. So you're replacing y with 2x plus 2, which is what happens when we substitute something, isn't it? When we sub off a player, we have to replace it with something else. We sub out y, we must replace it with something else. So I'm going to write sub 2a into 1. Why am I doing all these steps? What's the reasoning behind that? I'm doing my exam. What am I trying to get? My working mark, correct? I need to show my working the whole way through. Is it easy to follow what I'm doing?
Yeah.
That's what you need to be trying to model with your own work. So I substitute 2a into 1. What should I write now, Aiden? What should I write now?
I'm not sure.
Well, what does substitute mean?
Replacing.
Replace. So what am I replacing y with?
1.
2x plus?
Yeah.
So in this equation 1, every time I see y, what should I write? 2x plus 2. So I've got 2. I'm going to write it in red just so we're very clear. 2x plus 2 plus 4x equals 10. Very good. Happy with that, Brock, or not? Is that alright? What do you reckon I've got to do now? What looks gross? The brackets, hey, can we get rid of those? How do we get rid of those bad boys? Expand it in. So what's the operation that happens when we expand? Multiplication, so what's it become? Someone wants to write here. 4x plus? Yep, oh sorry, plus 4x, yep, you're right, equals. Very good, what do I do now, Atari? Oh, iPad down, that'll big one big hint, you don't need that, put it all the way down, don't need it. Brady, what do you reckon I should do?
Try and get X.
X's together? Yeah, I want to get it by itself and I want to get all the X's together, don't I? So what's this going to become? 4x plus 4 plus 4x. Should I rewrite that some way? How should I rewrite it? Well, how many X's have I got? 8, so 8x equals. What should I use now? Starts with yeah, rearrange, but using what process? Reverse bomb dash. I've got a multiplication and a addition. What do I attack first, Rowan? Yep, how do I get rid of her? Take 4. 8x equals? 6. What do I do now? Divide by 8. I'm left with x equals? 0.75 for my fraction-fearing friends, and for those of us who love fractions, 3 on 4. Or, yeah, 3 on 4 or 6 on 8 if you don't like simplifying. All done, right? Am I all done? Then why am I writing 3 on the board?
That's what x.
That's my x coordinate, so what do I need to find? So what should I do with 3? So over here, I'm going to just give myself a little bit more room. Sub, what should I write? Sub 3, where? Where am I subbing 3? Into?
1 or 2.
1 or 2, which one looks easier?
2.
I reckon 2a. How good does 2a look? Don't even need to rearrange. 2a. So y equals, what do I write now? Aiden, help me out. What do I write now? Y equals, what am I replacing x with?
2A.
Yeah, so what's, oh, I'm replacing 3. So what was 3? 3 over 4 or 0.75. So whichever one I like. 2 times, I'm going to use 0.75 because you guys are fraction fearers. Plus 2. What's 2 times 0.75? 1.5. Plus 2? 3.5. What's my coordinate? Y equals 3.5, x equals 0.75. Cool? That is substitution. That's my preferred method. The reason why I like substitution is it always works, and it's one less thing for me to remember. There are a few scenarios where the method I'm going to show you in a second is preferred. Cool? I'll give you a chance to write that down, and then I'll start doing our third method.